Over the last 14 years, the Areopagus has sponsored over 300 seminars and forums on topics related to Christian apologetics, history, science, significant books and films, and contemporary cultural issues as well. We also sponsor in-depth semester-length seminars on many topics here at Perimeter Church on Tuesday evenings and at Johnson Ferry Baptist Church on Wednesday evenings as well. Now, the purpose of our forum series is to address issues of particular significance to contemporary and thoughtful Christians, also to stimulate critical thinking, and to provide a venue for outstanding Christian thinkers, scholars, authors, and activists to share their thoughts and their works. Our next Areopagus Forum will be next month on Thursday, March 15th, and the topic next month is the opioid epidemic, the origins, the current crisis, and what we can do about it. And we'll be sending out announcements on this forum as soon as we've confirmed all the details, but of course a vitally important issue in our society today. Now, as usual, following our presentation this evening, we'll have a Q&A session moderated by Bruce Phillips. And as we typically remind our audience, please keep your questions as brief as possible so we can get in as many as possible. No pontification. And for more information on the ministry of the Areopagus, of course, including a lot of our publications, we have a literature table in the back there. Also, if you're not currently on our email contact list and would like to know about upcoming seminars and forums, you can sign up back there as well. And then finally, as we again remind our audiences, please keep in mind that the views expressed by our speaker do not necessarily represent that of the Areopagus or our host church, but they probably will tonight, actually. And we're very fortunate to have, as an integral part of the Areopagus, Eric Smith. And Eric is truly one of the most gifted people I know. He earned degrees in physics from Georgia Tech and Vanderbilt University. He was a member of the Nobel Prize-winning Supernova Cosmology Project. This was very groundbreaking. They were the discoverers, actually, of dark energy. And if you have questions about dark energy, I know I would direct them to Eric this evening. Now, for several years, Eric taught physics and astronomy at Southern Polytechnic State University and at Kennesaw State University. Eric and his wife, Andrea, have been, as I said, very active with the Areopagus for many years. He's also very involved in the Atlanta area chapter of Reasons to Believe, which several of us are involved in that. In fact, the president of the local chapter of Reasons to Believe is with us this evening, Rod Nave. Rod, where are you? Yeah, would you mind standing? And so if you have any questions about that organization, many of you are probably familiar with the work of Dr. Hugh Ross. He was the founder of Reasons to Believe. And so seek out Rod if you have any questions. We meet on a regular basis every month, virtually every month of the year, out at Johnson Ferry Baptist Church. Now, getting back to Eric here, he's the co-author of the study guide for the book that I wrote, Introduction to Bibliology. And when I'm out of town, Eric regularly fills in for me in my Sunday morning Christianity Through the Centuries class at Johnson Ferry. He's also very well versed in philosophy and Christian apologetics. And I often say that he's really the only astrophysicist I know who I would trust teaching history, okay? So in addition to astronomy and astrophysics and history and apologetics, Eric's interests include literature, in particular science fiction literature, and popular music from the 1960s to the present. He's also an amateur author and songwriter, and over the years I've noticed there's really only one flaw that's obviously detectable in Eric, and that is that he likes Paul McCartney's post-Beatles music, which never ceases to mystify me. But Eric and Andrea, of course, live in Marietta, and they have a daughter, Perrin, and so I know many of you are at least casually familiar with Eric. I think you'll enjoy very much his presentation this evening, and please provide a very warm welcome to Eric Smith.
Well, thank you, Jeff. That's not too much to live up to, I think. So tonight we're going to be looking at the question, was the universe made for mankind? And this question is the driving force beyond what is often called the teleological argument. And that's a big word, but it comes from the Greek word telos, which means end or purpose. And the basic idea behind the argument is that God designed the universe with a purpose in mind, and that purpose was to provide a home for humanity. And that the universe was designed for this, and that all the aspects of the universe that we know can be explained by God designing it for people. Now, what I wanted to look at tonight, I'm going to try to take sort of a different tack than you might normally would. A lot of times if you mention this to someone who has a passing familiarity with science, not an actual scientist or something, but someone who has some idea of what science is like, they might have a few objections. Some fairly basic, straightforward objections to the idea that the universe was made as a home for humans. And what I want to do is look at some of these objections and see how they really aren't detrimental to the argument, but actually provide support for it when viewed at properly. So the first question I like to ask is, if God designed the universe for people, why is it so huge? Because the universe truly is an enormously, monstrously, unbelievably huge place. A good example of this is this picture. This is what's known as the Hubble Ultra Deep Field. And this picture was taken of an area of the sky about the same size if you took a dime and held it out at arm's length. The size of the eye on that dime, from your point of view, is how big an area of the sky this is looking at. And this area of the sky didn't have any stars or anything near it. It looked blank until they pointed the Hubble at it, took several long exposures, and what they got back was this photo. And those aren't stars. Every point of light you see in that photo is a galaxy made of hundreds of millions or billions of stars in and of themselves. And again, this is just the tiniest fraction, 1/13 millionth of the sky. So if you generalize it out to the entire sky, we end up realizing that in the observable universe, the part of the universe we can see, there's about 200 billion galaxies. And so the universe is a truly huge place, and these galaxies, are, enormously far apart. And so the objection goes, well, there's all this space out there that humans don't live in, that humans will never reach. If God made the universe for humans, what's the point of all this? Why have all this space? Why have all this matter, this stuff out there that's not doing us any good? And in fact, this objection is so popular that some of the big heavy hitters have contributed to it, like Victor Stenger, well-known atheist, stated, if God created the universe as a special place for humanity, he seems to have wasted an awfully large amount of space where humanity will never make an appearance. Also, Stephen Hawking, who I'm sure some of you have heard of, said, our solar system is certainly a prerequisite for our existence, but there does not seem to be any need for all these other galaxies. So I want to look at now, why is this there, and why are all this space and all these galaxies actually necessary for people? God didn't put them there for no reason. Well, a lot of it has to go into the conditions that we need for our universe. Because it turns out the universe has to be both vast and massive to support human life. It needs all this space. It needs all this stuff to actually be a home for humans, even if we'll never actually reach any of it. And it really goes back to the Big Bang. When the Big Bang happens, the universe is very small and it's incredibly hot. Hotter than anything you might see today. And in order for life to exist, the universe had to cool down. And the only way that the universe could cool down was to expand. And it had to expand to an enormous size, or else the universe would simply be too hot for anything like people or life or even planets and stars to exist. So the universe is expanding, getting larger and larger, cooling down to what it is today, which is just a couple degrees above absolute zero. So incredibly cold. But it couldn't just expand willy-nilly. It had to expand at the right rate. So basically, this rate depends on what's called the mass density of the universe. How much matter is out there? How much stuff is in the universe to make it expand right? Because if there's too little stuff, the universe will expand too fast, because there's not enough gravity to slow it down. If there's too much stuff, the universe won't expand fast enough. If the universe expands too fast, basically you end up with a universe where matter is so spread out and so low density that you can't get stars at all. Matter is so spread out everywhere, stars don't form, galaxies don't form, planets don't form. So we don't want it expanding too fast. If it expands too slow, you get a universe of nothing but black holes, essentially. Mass is too densely packed, you get a bunch of black holes, and they suck everything up, and again, no life at all. So the amount of stuff in the universe has to be what it is to get that expansion rate just right. So we need a large universe to cool down. We need a universe filled with these galaxies to make sure it cools down properly. So both size and density are important, and they're not just important, they're critical. And it turns out that this is really balanced on the edge of a knife. Just a little bit one way or the other would cause disaster. And to get the universe to expand just right, just the right rate to just the right size, this density, this amount of stuff in the universe has to be accurate to 1 in 10 to the 60th power. 10 to the 60th is 1 with 60 zeros after it. Has to be that accurate. A little bit either way, and the universe simply does not work. And so, to say the universe is too big, or that there's too much stuff out there that we'll never use, really is missing the point. Even if we never get to it, it had to be there to allow people to exist. And it had to be exactly as it is for humans to exist. Any change at all, and the universe is awash. Nothing happens. So, answer to this question, conclusion here, the small size of humanity is not an indicator of our importance. Size doesn't matter. You know, it doesn't matter that humans are a speck on a speck on a speck on a speck in this huge universe. It doesn't make us any less important. That doesn't mean that the universe is not made as our home. The size of the universe is exactly what it needs to be to allow humanity to exist. And also, on sort of a personal note, to me this argument, even if the science wasn't there to contradict it, I think it has a very small view of God. Because we can't reach those galaxies, but we can see them, and we can be awed by this beauty and grandeur that God's created. And even the galaxies, the universe that we won't see, God can still appreciate. There's beauty to the universe. And it seems to me like you'd have a very small view of God if you object to God making this incredibly awe-inspiring thing. Without, there's, truth and value to be found just in beauty. And again, that's not a scientific argument, but it seems to me that the kind of people who would object to this really don't have a full understanding of the nature of God and the nature of people, that we can appreciate this kind of beauty. So that's one argument that you might encounter, and a lot of times it's the first thing people bring up. The universe is so big, we're so tiny. Isn't it arrogant to think that it's there for us? Another argument you can encounter: if God designed the universe for people, why is it so old? And this is another big one, because the universe is very old. Here's sort of a timeline. There's our history of the universe, Big Bang onward. Lots of stuff happening right at the beginning, slows down as you go. But the universe is about 13.7 billion years old. So truly an enormous amount of time. Our sun, our solar system, our planet, has been around for about 4.5 billion years. On the other hand, people have been around about 100,000 years, give or take, 50 or so thousand. Still some debate on that. But either way, and it's sort of a common exercise to imagine the history of the universe squeezed down into a year, in which case, you go through the first 8 or 9 months before you even get our solar system, and you're down to like the last fraction of a second before you get humanity. So, if we're so important, why did God wait so long to get to us? Was he just bored? Was he a procrastinator? Why wait so long to get us? So let's look at some of the reasons. And there's a lot. This to me is, has the most to say, because the timing for humanity is so incredibly critical and really suggestive. So the first thing we need to have a home for humanity is you have to have the right materials. And again, because, life requires carbon. We're carbon-based life forms. Life requires water. Life requires all of these things, all the stuff you take in your, vitamins every day, iron and nickel and magnesium and all this stuff that life requires, we have to have. So, life could not have existed immediately after the universe was formed. It had to wait for this stuff. Because when the Big Bang happened, again, 13.7 billion years ago, all the Big Bang made was hydrogen and helium. A little bit, like a trace amounts of like lithium and beryllium maybe, but mainly hydrogen and helium. And in fact, the universe even today is 99% hydrogen and helium. That's most of what's out there. And that's all that gets made in the Big Bang. So if it had stayed that way, if the universe had stayed hydrogen and helium only, again, humans couldn't exist, life couldn't exist. A planet like the Earth could not exist. The Earth requires these heavy elements. And all of these heavy elements are made inside of stars. So you might have heard the phrase that we're all stardust. And that is quite literally true. Everything in our body that's not those two elements of hydrogen and helium had to be made inside the core of a star. That's the universe's factories. And the really heavy elements, things like iron that we need, or even things like our civilization needs, like gold and silver and the like, those are only made inside exploding stars called supernovae. This is what happens to really massive stars at the end of their lifetime. They explode and create these really heavy elements. So, Big Bang goes off, only hydrogen and helium. Eventually, the first stars start to form, and that takes a bit of time. These first stars are really big. They don't last very long. They explode. And all the stuff that they made inside them, all this heavier material, when they explode, gets seeded throughout space. It gets scattered out there. But there's still not nearly enough of it, enough of a concentration to form things like rocky planets like the Earth. So we had to go through a second cycle. New stars needed to be formed and create more of this material and explode and seed the universe. And it probably took about 3 of these cycles or so before you got enough of this heavier stuff, a high enough density, a high enough concentration of this material out there to actually form a planet like the Earth. These early stars could not have had planets, certainly could not have had rocky planets. So this actually takes about the first 9 billion years of the universe's existence. So Any earlier than 9 billion years, you're not getting rocky planets like the Earth. And you certainly don't have enough material, enough of these heavy elements to allow for life and to allow for human civilization. So interestingly, 9 billion years is roughly about when you start to see life arise on the Earth. So we aren't an afterthought. The Earth and life appeared about as soon as it possibly could in the history of the universe. Any earlier and it simply would have been impossible. So that's one reason why, if we're so important, we had to wait so long. We had to wait for all our building blocks to be constructed. Another thing that a lot of people probably don't think about much, the Earth has a molten core. Most people know that, volcanoes and the like. The Earth's core is made of molten rock and metals like iron and nickel and the like. And this molten core is critical. There are several things about the molten core that allow life to exist on Earth. One reason is that it drives what's called plate tectonics. Again, a lot of, you've probably seen, pictures of where the Earth looked like in the past, how the continents shift around and move around and form all these different shapes. That's due to what's called plate tectonics, that the Earth's surface is divided into about 12 different huge slabs of rock that keep moving around and shifting. And this plate tectonics, this shifting of the land around, is nature's recycling system. That it brings up new rock from under the ground, and it takes old rock, shoves it back into the ground to be recycled. And this replenishes the Earth's surface with the minerals and the nutrients that life needs. Without that, we would very quickly run out of nutrients, and eventually even the continents themselves would get worn down and flattened, and the whole Earth would be an ocean. So plate tectonics, absolutely necessary for life. And we wouldn't have that without the molten core. Another important aspect to the molten core is in the molten core that the Earth's magnetic field is created. What compasses respond to. And in addition to allowing us to use compasses for things like navigation, the magnetic field on Earth is critical because it's protecting us from the sun. The sun is constantly shooting out radiation. Basically, little tiny particles, protons and electrons, with an enormous amount of energy that, if we weren't protected from them, would gradually strip away the Earth's atmosphere. So we need a shield, like in Star Trek, something to block these particles. And our magnetic field is that shield. And without the core, we wouldn't have that. In fact, you see that on some other planets like Mars that don't have a molten core. They don't have that magnetic field. They've lost their atmosphere. So you have to have a molten core to support life. Now, the reason the Earth's core is molten is for a couple reasons. Part of it, is that when the Earth first formed, it was very hot. In fact, the whole Earth was just a big ball of melted rock. And it cooled from the outside in, which is what you'd expect. Space is cold, it cools the outside in. And so for a while at least, the core would have stayed molten just from that. But if that's all there was, the Earth's core would have cooled off by now. So we're kept molten by these radioactive materials in the core. Everyone's heard of radioactive stuff. Radiation produces heat. And as these radioactive materials decay, they give off heat that keeps the Earth warm, that keeps the core molten. And that allows things like plate tectonics and the magnetic field and other things I'm not even going to get into to keep going. So, how does this tie into the age of the universe? Why it's important? Yeah, I mentioned that. Well, again, the Earth's core is powered mainly by these radioactive materials now. But radioactive materials, by their very nature, don't last forever. They decay. They change from radioactive to non-radioactive things. And it doesn't take that long. Certainly over the course of the history of the universe, all of these radioactive materials would decay away and be gone if they weren't being, made again by new stars. So early universe, no radioactive materials. As stars begin to form and die, you get more and more of them, but they also disappear. So you have this battle going on between radioactive elements being made, radioactive elements disappearing. And so over time, you get more and more and more density, more of this radioactive stuff out there. And about 9 billion years, again, after the universe starts, you reach a peak. That sort of, you've heard of peak oil, this is peak radioactive. This is when there's the maximum amount of radioactive stuff in the universe. After that, it starts to go down. So the Earth forms right at that peak. It gets the maximum amount of this fuel, basically, that's in the universe. And that's what's still keeping our core going. So, again, 9 billion years necessary to get these heavy rocky materials to form Earth, to form life, necessary to get these radioactive materials to keep our core going. Another reason that our appearance came along at just the right time was for our own safety. The early universe was a very, very dangerous place. We've mentioned supernovae already, these exploding stars. And again, they were necessary, but obviously they're also very dangerous. A star explodes near you, you're gone. A star exploding, hundreds of light years away from us could sterilize the Earth. So we can't be anywhere too close to one of these things. And the early universe was filled with exploding stars. It would have been far too dangerous for humans to live in that kind of environment. We had to wait until it settled down. Another thing are what are called gamma ray bursts. Gamma ray bursts are enormous explosions in space. We see them on average about once a day. Somewhere in the universe, once a day, there's an enormous explosion. These are actually the most energetic things in the known universe. So you have this enormous explosion of gamma rays, and these would also be very, very, very dangerous. Again, if one of these goes off near the Earth, it destroys our ozone layer, it could destroy our atmosphere. Very dangerous for life. In fact, we think that might have happened at one point in the past. There's one of those mass extinctions several million years ago that could have been caused by one of these. But again, the early universe was filled with these gamma ray bursts. They were happening all over the place. And they didn't die down until after about 10 billion years. So you have the Earth coming along around 9 billion. Finally, the gamma ray bursts are dying down after about 10 billion, and the universe becomes a bit more friendly to life. You also have galaxies colliding and merging together. The early universe is filled with galaxies in collision. And you don't want to be in a colliding galaxy. Their planet would get thrown into these huge dust clouds and nebulae and things that would, again, destroy the atmosphere and the like. So we had to wait for that to settle. And a lot of young stars, they actually go through a phase that's referred to as stellar adolescence, where they're very active and they're very disruptive. Yeah, I'm not joking. That is actually what they call them. It's stellar adolescence. Happens fairly early in their lifespan, and they go through a very destructive, active period. Technically, they're called T-Tauri stars, but this is funnier. So all of these are problems in that early part of the universe. And again, they all start to die down around the same time, about that 9 to 10 billion years after the Big Bang window, which is when the Earth comes around. So life, the Earth itself wasn't possible until around 9 billion years ago. Life wasn't possible until around 9 or so billion years ago. Advanced life, like us, which is a lot more delicate than like these small, one-celled organisms, had to wait even longer. We had to wait until the universe was a safe enough place for us to be. But as soon as it's possible to have life, it appears. And life itself is an incredibly unlikely thing. So the idea that life shows up as soon as it appears indicates that the universe really was waiting for that to happen, or someone was waiting for that to happen and was ready to act as soon as possible. So our conclusion here, humanity is not an afterthought. It's not like God, got bored after 9-10 billion years and said, okay, let's try something new. I'll call it life. Everything was leading up to it. Everything was building towards the appearance of life. And so life, advanced life, and humanity all appear as soon as it's possible for it to do so. Even human civilization is timed to coincide with a very stable point in the lifespan of the sun. Humans show up and start building civilization right as the sun is kind of settling down. So there's very, precise timing in all of this. So the age of the universe isn't a detriment, it's actually a necessity. Another thing, and this is somewhat less popular, but you will hear it. If the universe is made for people, why are we not at the center? Some of you might have seen t-shirts with this picture. This is our galaxy, an artist's representation of our galaxy. And yes, that is about where we are in it. We are not at the center. We're nowhere close to the center. Our galaxy is actually on the edge of its group of galaxies called the local group. That little group of galaxies is on the edge of a larger group. We're not at the center of anything. Mankind is the country bumpkin of the universe. We're out in the middle of nowhere. We're in a medium-sized galaxy. We're in an out-of-the-way galaxy cluster. We're orbiting a sun that's very far removed from the center of that galaxy. And our planet is dwarfed by several of the other planets, even in our own solar system. So we certainly, if size is an indication, if centrality is an indication, we don't seem to be that important. So, is that the case? Why are we where we are? Well, as it turns out, not surprisingly, where we are is absolutely critical for life. It turns out that we couldn't be at the center of our galaxy. Most galaxies couldn't support life at all. Our galaxy is rather unusual just in that. But even in galaxies that could, you couldn't have life anywhere. There's actually a very narrow ring right around here where you could have life at all. If you're closer in than that, all this radiation from the center would kill you. If you're further out than that, there's too little stars to have the materials necessary to form rocky planets and life. So there's this very narrow band right around here where life is even possible. And we refer to that as the galactic habitable zone. So being at the center, wouldn't make us important, it would make us dead. It's also very important that our galaxy be off on the edge of our little group of galaxies. Because again, galaxies in these groups are always moving around, they're colliding all the time. And again, we do not want to be in a galaxy that's colliding with another galaxy. We probably get blown into some huge dust cloud, gas cloud, or something that would be very detrimental. So, we want to be out of the way. We want to be on the edge. Most galaxy clusters out there are incredibly densely packed. You might have thousands of galaxies packed into a really tight space. Our own galaxy cluster is actually very, very loose. We have a few dozen galaxies. We don't have thousands, and they're fairly spread out. There's only actually one other large galaxy in our group, and it's 2 million light years away. So we're not in any danger anytime soon. But in most parts of the universe, we would be. Most galaxies in the universe are packed in these tight clusters. So, again, primacy of place does not imply primacy of position. Just because we're not at the center doesn't mean that we're not important. Our position protects us from what would otherwise be a very hostile universe. Life is not possible everywhere. Science fiction, Star Wars and the like may make it seem like every planet out there could maybe support some kind of life. Every star has a planet or two that could support life. It's just not true. Our position is very sheltered, it's very particular. And really, it's quite unique. And almost very little about our star and our galaxy is typical. A lot of times you'll hear people say differently. They'll say, oh, the sun is a very average star. It's not average. Where its position is not average, its stability is not average. There is nothing average about our spot in the universe. So, those are three sort of non-technical questions that are the first things a lot of time come to people's mind when you tell them that the universe was made for people. Now, if they know a little bit more about science, they'll hit this one. But what about the multiverse? And this is sort of the, current celebrity among sort of people who want to debunk this argument. That basically, our universe is not the only universe. There are plenty of other universes out there. They'll say there's an infinite number of universes out there. And if there's an infinite number of universes out there, then anything that could theoretically happen not only can happen, it will happen. And it will happen an infinite number of times. So us being here, isn't chance. It's the inevitable result of throwing infinities in any probability. When you have an infinity of something, no matter how improbable it is, it can and will happen. So, this is sort of what they think of as the sort of killer argument. So, to understand this, let's ask the question, well, what is the multiverse to begin with? Because you say multiverse or other universes, people get this sort of idea of it's like the parallel universe where everybody is evil and has a goatee. That's not the scientific idea of the multiverse. It's not as sci-fi as that. Rather, to get an idea of what the multiverse is, imagine this huge space that's constantly expanding. Very, very, very rapidly. All the time. And inside this very rapidly expanding space, occasionally you'll get sort of these little bubbles that pop up. They're expanding more slowly. I could get technical about it, but let's just leave it at that. So you can think of these as sort of bubble universes. There are smaller regions inside this much larger space that sort of just pop up at random. And they're expanding more slowly than the rest of it. And each of these little bubbles is essentially its own universe. It's cut off from everything else out there. Whoever's inside this bubble is never going to be able to get out and see this larger space. So it's a self-contained bubble universe. Now, as sci-fi as this sounds, it's not completely without scientific basis. There are current models of the Big Bang. It can be tricky to get them to work without some kind of multiverse. The multiverse, in a way, is sort of a natural outgrowth of it. So it's not, some people think, well, the multiverse is what people came up with to try to dismiss design arguments and all that. It isn't. It has a legitimate scientific basis, but a lot of people try to latch onto it to make it do more than it's supposed to do. And it really comes down to this idea of infinite possibilities. That with an infinite number of universes out there, there's an infinite number of possibilities, that our universe wasn't made for us. There just happened to be a universe that was just right for us. And so, of course, that's the one we're going to be in, because we can't be in the ones that aren't right for us because they're not right for us. So, is this actually a defeater? Does this cancel out everything I've said and everything anybody's ever said about fine-tuning or, design or anything like that? Well, it turns out no, because there are a couple of unspoken but critical assumptions that go into this argument. Assumptions that are not required by the actual multiverse theory, but people make them. And the first is that there is an infinite number of these universes. That you have not just a few universes, but a literally infinite number of them residing in an infinite space that's been around for an infinite amount of time, so that there's time to produce these infinite universes. This is not a requirement of the multiverse theory, but it's something that people like to throw out there. Now, there's a lot of problems with this, because in order to have an infinite number of universes, this larger sort of uber space, the big space that all these universes are in, at least one of two things has to be true about it. It either has to be infinitely large to contain these infinite number of universes, or it has to have existed for an infinite amount of time to have the opportunity to create an infinite number of universes. You can't create a finite number of universes you can't create an infinite number of universes in a finite amount of time. So, at least one, if not both of these things have to be true about this larger space for this assumption to work. And again, this is a pretty critical assumption. The problem with that, however, is that infinities, like infinite time and infinite space and infinite universes, they work great in math. You can throw infinities and math all over the place and do great stuff with it. In science, however, anything infinite becomes a lot more problematic. Now, infinities in science work great for things like approximations. A lot of times in my science classes, we'll calculate the magnetic field of an infinite current. Well, obviously there are no infinite currents out there, but it works well as an approximation for a magnetic field close to your current. And so infinities can be useful in science in that way. But in actual physical infinity, there's, a lot of people would claim that it's simply not possible. It raises an enormous amount of paradoxes to have an infinite number of something. Just to give you an idea, we talk about an infinite number of universes. Well, let's say there is an infinite number of universes. Not all of them will be able to support life, but some of them could. So there'd be an infinite number of universes that could support life, but not as much of an infinite number as there are universes. And then there'd be an infinite number of universes that could actually have life, but not as much as an infinite number of the universes that could support it, or the infinite. It becomes ridiculous. Everything becomes infinities and nothing works. There's also a real problem with the idea of anything existing for an infinite amount of time. Essentially, think of it this way. Let's say we're right here, right now, this time. If the universe had been around for an infinite amount of time before now, how would we ever reach this time? If you have to wait for an infinite number of seconds to pass to reach this point, you can't wait an infinite number of seconds because it literally never ends. So just logically saying anything has been around for an infinite amount of time has problems. Also remember, I said that this bigger space was expanding. And it's been shown scientifically that any space that's expanding has to have a beginning. It doesn't work. If you're expanding, turn time back, you get smaller and smaller and smaller. Eventually you hit nothing. Scientifically, any space that's expanding has to have come from a beginning. It could not be infinitely old. But you have to have an infinite space that's infinitely old to get these infinite universes that people assume are there. So that assumption kind of doesn't work. The other assumption is that with these infinite universes, there are infinite combinations. The idea is this, that our universe has exactly the right properties that allow for the universe itself to exist and for life to exist. If you've ever read anything about fine-tuning, you've heard about this. The strength of the forces in atoms is exactly right. The amount of entropy in the universe is exactly right. The proportions of matter and energy is exactly right. So you have all these precisely set combinations that allow for life to exist. Now, what people propose here is that that each one of these separate universes would have its own set of values. It would have its own combination. Maybe in our universe, the gravitational force has some strength. In this other universe, it would have a different strength. And the electric field would have a different strength. And all these other constants would be different. And basically, each universe gets its own randomly generated set of constants. So that, if there's an infinite number of them, eventually you're going to hit on a universe that has just the right constants for life. And in fact, there would be an infinite number of universes with just the right constants. So this is their second big assumption, that with infinite universes come infinite combinations, infinite possibilities. The problem with that is that that is an absolutely unfounded assumption. We do not know why our universe has the constants it has, why it has the values it has. They might be random. They might also be the only possible ones. We simply don't know. We don't understand where they come from. So to say, even though we don't understand where they come from, to say they would be different somewhere else is an enormous leap. It is a completely unfounded assumption. But it's absolutely required for this idea to work. To say that we're here because we have to be here, because there you have an infinite number of universes and an infinite number of possibilities, and just one of them happen to be just right for life, requires that we have a truly infinite amount of things and that they're random. And neither of these are required by the theory at all. They're merely assumptions that people have made. They've imposed upon it. So what can we say about this? The multiverse may very well exist. Again, current models of the Big Bang more or less require it. There are some models that don't, but most of the ones people come up with seem to require some kind of multiverse. So it could very well be there. But for this multiverse to negate the need for a designer, you have to add onto it a number of unproven and maybe impossible assumptions in order to make that actually work. And so even though it's the popular thing to say right now, fine-tuning, design, all this doesn't work because we're just one of a part of a multiverse, really doesn't hold water. There are too many unproven assumptions there that you have to make that statement. And indeed, as some people pointed out, if the multiverse itself is there, it actually has to be fine-tuned as well. And there's a lot to be read about that. I'm not going to go into it, but you're really just shifting a lot of these difficulties back a step. Well, maybe our universe isn't fine-tuned, but the multiverse may have to be. So, what does all of this say about God? Do all of these prove that the universe is created by God? Do they prove that the universe was created as a home for us? Well, no, it doesn't prove it. But it's suggestive. It does tell us that the universe is exactly what it needs to be to allow us to exist. And what appear to be drawbacks, what might appear to be objections to this idea, are actually necessary for it. That the things that might first make us appear to be an afterthought actually just make us the culmination. We are what the universe has been building up to for 13.7 billion years. That there was an enormous amount of time and work and preparation that went into allowing us to be here today. And this is certainly suggestive, not proving, but suggestive of some kind of designing intelligence. That we're here as soon as we could possibly be here, and that everything is right for us in a way that chance doesn't seem to allow for. And that's all I have to say.
Thank you, Eric. Thank you very much. I always feel smarter when I listen to Eric, so it's always a good thing. We can always use a little bit of smart, so thank you very much for that. We've got 2 mics. Suzanne has one in the back. I'm here because we're taping this, so we'd like to get the voices on tape so that there's nothing more annoying than watching a video presentation of something and you hear no question and then you hear an answer. So we're going to try to take care of that. If you would be so kind as to make your questions, there's a concept, right? That would be great. And particularly ones that have answers, that would be great. I'm sure Eric will do his best to answer them as quickly as possible, and we'll see how many we can get through. Jeffrey, we've got until 9 o'clock? Yes, it's about a half an hour, so we'd like to cover as many chances as we can. So who would like to? Bob Christensen would like to ask the first question.
Great presentation, Eric. Thank you. Hey, Stephen Meyer likes to talk about inference to the best explanation. And if we talk about scientists either, sort of having an openness to a designer versus those that have a closed mind to that idea, need a materialistic explanation. My question really is, is there any traction to that idea of inference to the best explanation? I mean, many of the things that you've said here basically follow that pattern as giving evidence for the existence of a creator. But do scientists follow that train of thought at all?
I think it's very important that inference to the best explanation, something called abductive reasoning, is something that is certainly used in science. People have this idea of science as being a very sort of cut and dried thing, that you take your data and there's one possible answer and that's your answer and that's what science says. But that's really not how it works at all. Scientific data is oftentimes very messy. Believe me, I spent several years in grad school looking at objects half a universe away, and they were messy pictures from that far away. And a lot of times your data can be fairly wild. It can have all these anomalies that don't make a whole lot of sense. And you had to sort through that. And you had to say, here's my good data, I don't accept this, and this is why I don't accept it. And then you have to build your model, build your conclusion. And there's always more than one possible conclusion. Sometimes the correct conclusion is fairly obvious. Sometimes it's not obvious at all. And the more we dig into these really advanced topics like quantum mechanics and relativity and all this stuff, the harder it is to decide what model our data is pointing us towards. And usually what we have to come back to is this inference to the best explanation, this idea of the data fits all these different possibilities, but what seems to be the best one? What seems the simplest? What seems to present the least amount of problems? And oftentimes that's right. Sometimes it's not. A great example of that is gravity. Back 1600s, Sir Isaac Newton comes up with this theory of gravity. And it fits all his data. It's the simplest explanation, the simplest equation he can come up with, and it seems to work. Now, there are other equations that could have worked as well, but they would have been more complicated, so we didn't go with those. And we use his equations for about 300 years until Einstein comes along and says, no, wait, we have new data now, or I've thought through this a bit more carefully, and it turns out that Newton's simple equation wasn't right. That we really need this much more complicated thing to explain gravity. Now, Newton could have come up with Einstein's equations. They would have absolutely worked with what he had, but there was no reason for him to consider something that complex. It took more sophisticated data and someone else to realize that the more complex solution was the best one. But again, it was then an inference to a best explanation. Einstein's theory was the best explanation he had for his data at the time. We may later on find that he was wrong and there's something even more complicated we hadn't thought of. So people, sometimes dismiss this kind of abductive reasoning as weak, as, oh, you're not proving anything, you're just guessing. But that's not true at all. Science is always about picking between things. The data never tells you anything for certain. And so ultimately, most science will come down to some kind of inference to the best explanation. And really, most people's everyday life comes down to inference to the best explanation. You know, this is what we live by. We don't usually sit down and think logically through all the possibilities of everything. We assume what seems to be the best answer. You know, if I'm woken up at night by a baby crying, I think it's because my daughter's woken up and had a bad dream. I don't think it's because, you know, somehow the television turned on by itself and tuned to a TV show with a baby crying on it. I mean, it's possible, but that's not the best explanation. And so, yeah, I think this abductive reasoning is not only important, it's absolutely critical for science. It really is what defines science.
I think it's an incredibly interesting area. We could spend an evening on that, but we're not going to. Not unless somebody else wants to ask. Yes, in the back.
Eric, I'm Terry Martin. In view of the discovery of so-called Earth-like planets, wondering if we know enough about where they are to say if they are within the habitable zone of their respective solar systems.
Well, to answer that, first you have to define the term Earth-like. And unfortunately, this is one of those things that I think the media blows out of proportion more than science would. Never, ever trust what the news is telling you about science. They'll latch on to anything and sensationalize it out way more than the original scientists would. I remember last year, there was a big discovery of 7, quote, Earth-like planets around a single star. And it was a very exciting discovery. And it was very exciting to the scientists that made it. It was a big announcement. But of course, the news media immediately jumps on and says, we found planets, 4 planets with life. And it's, again, way, way beyond what is justified by the actual paper that these scientists have presented. So that's one thing to keep in mind, first of all, when it comes to these, quote, Earth-like planets. Another is that when a scientist, you know, someone like NASA says Earth-like, what they usually mean is there's a possibility that liquid water could exist on this planet. It's at the right spot around its star so that it may be able to have liquid water. And you know, Earth-like also meaning it's a rocky planet and it's relatively small. You know, they call planets 5, 6 times the size of the Earth Earth-like. But, you know, compared to Jupiter, that's not a big difference. So that's what Earth-like usually means. Rocky, not too much larger than the Earth, and can have liquid water. The problem is that an Earth-like planet to be truly Earth-like, to be truly capable of supporting life, would have to have way more than that. There's something like 160-something requirements for a planet to be truly Earth-like at last count, and that may have gone up since the last time I looked. And they're saying that these planets might satisfy 2 of these, or 3 of these. So take any announcement of a, quote, Earth-like planet with a grain of salt, because most likely they're nothing like the Earth. They just happen to have a couple of things in common with us. Now, I would love to hear about a truly Earth-like planet being discovered. I think that would be incredibly exciting. Hey, I'm a sci-fi fan. You know, I would love that. But yeah, anything you hear about it, do the research, look into what they're actually saying, and take it with a grain of salt.
Oh, I said, Mario,
Hello, Mario.
You've got to have a question.
Yeah. Hey, Eric. Thanks, that was great. You were saying that the constants that the universe has, right, are the ones that are necessary such that we could exist, right? So, and these things are like electromagnetic constants, right, or other constants like or
gravitational constant, fine structure
right,
constant,
like
all that
Planck's
sort of
number
thing.
and things like that, right? So the conditions are just right for us to exist. But also from your last slide, right, we can say that that doesn't prove or disprove that there is a God.
Yeah.
Is that right?
Yeah, it's suggestive, but it doesn't prove.
Right, but on the other hand, right, you can have 2 separate arguments, right? Because there's no reason for us to not think that God set the universe in motion through the Big Bang, and the universe expands, and then over time planets form and so on. But we could also say that He is involved at every step, right?
Yeah.
And so when the right conditions on Earth form for life, then he says, okay, well, I will create man, right? I guess my question is, nothing that science has discovered necessarily goes against the idea that the creator was in the middle of it too, right?
Oh, no. And ultimately, I would say that it would be impossible for science to find something that would disprove God, partially because you simply can't prove a negative like that. There's nothing science could say that could tell you that God definitively does not exist. You could have science, say that these assumptions about the multiverse prove true, that there's somehow, beyond all rules of logic, there's an infinite number of universes out there with infinite combinations. Well, then you could say, well, God isn't required to have these constants be exactly right. That doesn't mean that God doesn't exist. It's just saying that for this particular thing, God may not have been absolutely necessary. Now, I think going the other way, science can't completely prove God either, but again, it's this inference to the best explanation. You have all these improbabilities adding up, and it becomes very suggestive, so that the simplest answer is that there is a designing intelligence. It's Occam's razor all over again. Maybe not. Again, you can't prove it, but it's the simplest answer to the question. And in science, usually we assume the simplest is the best.
We have a question down here.
At one point, I think you said something to the effect that as soon as it was possible, or the conditions were in place for life to exist, then life came into existence. That sounds a lot like spontaneous generation to me.
Well, and it would be spontaneous generation if naturalistic causes were the only cause. If God exists, then it's not spontaneous generation. It's, God putting life there as soon as it's ready for it. Yeah, if there is no God, spontaneous generation is the only answer you have.
What you're saying is he couldn't put life on Earth until it was...
Yeah, it wasn't ready. The time had not yet come.
That makes sense.
That's all you're hearing.
Thank you. I've heard the universe is expanding, and if so, how do we make that consistent with the belief that the Earth is just perfect given all conditions right now?
There's not really a contradiction. The universe is definitely expanding. We've known that for 100 years. In fact, the dark energy, which is what my graduate work is on, actually is making that expansion go faster. That was the big discovery. But you also have to realize that when we talk about expanding, it doesn't mean, one, that everything in the universe is getting bigger. Thank God. I don't want to be bigger than I am. It means that space is getting bigger, that distances between galaxies is getting bigger. And then this is where it gets bizarre, that the universe isn't actually expanding into something. It's not that these galaxies are moving away from each other. The universe is itself expanding. Space itself is expanding. So the galaxies are actually staying put. It's just the space between them that's getting bigger. It's like blowing up, like having a spotted balloon and blowing it up. The spots get further apart from each other even though they aren't moving around the balloon. It's the same kind of idea. And as I said, this expansion is absolutely necessary for life. You have to have it. Without that, the universe would not have cooled, and you would have a universe that was nothing but an incredibly hot ball of energy that probably wouldn't even have subatomic particles, much less planets and stars and life. So there's certainly no contradiction between the two ideas.
And if I may, correct me if I'm wrong, which is very likely. The universe gets big enough, there's enough space between us and the furthest thing that we can see today, such that the expansion rate can really mean that thing would appear to be moving away from us faster than the speed of light. Right? Even though it's not moving through space. It's that the space is getting bigger, and it's moving away so fast that it becomes unobservable. And one of the things that people have pointed out who are interested in the fine-tuning argument is that we happen to live at a time when the observational possibilities are as great as they could conceivably be, which has allowed us to see things which, if we lived another 110 million years from now, we wouldn't be able to see half the things that we can see because the expansion would have taken them beyond the time that it would have taken for light to reach us.
Yeah, I mean, we actually live, it's interesting because one of the first things you're taught in astronomy is what's called the Copernican principle, that there is nothing special about Earth's location in space or in time or anything else. But we actually live in a very special point in time. Not only are we the earliest that life could be, but we're living at a tipping point. We are living in the time where this dark energy that's making the universe expand faster is just beginning to take over. Before now, we really wouldn't have seen it. It's just beginning to take over now. The universe is really just starting to get going. So had we waited much longer, if God had waited much longer to put us there, we would not be able to see nearly as much of the universe as we do, because this stuff would be flying so far away from us that it would literally disappear from our sight. So we really are living at a very special point in time.
If that keeps you up at night, we're very sorry. Well, Suzanne? Okay, yeah, that's fine.
Eric, this question is coming from an individual trained as an engineer, so I wanted to qualify things. What are the processes, procedures that were used to determine the age of the universe and then the Earth itself?
Well, the age of the Earth, there are several different clocks we can use. A lot of it's radioactive decay. The universe really comes from taking into account what we see of the expansion now, how much matter we see in the universe, how much energy there is in the universe, and plotting out how all those would affect the universe over time, and then projecting it back. And then seeing, okay, everything comes together at this point. And there are also other things. We can look at distant universes, distant galaxies, and see how they're moving. We can even look back to the leftover heat of the Big Bang itself. It's what's called the cosmic microwave background. It is literally the leftover glow of the Big Bang. And that takes us back to around 400,000 years after the Big Bang happened. And so all of these together gives us dates, and they all agree. They all converge at that time.
Over here.
Thank you, Eric. Great presentation. It touched on a lot of the things that I remember reading about in one of my favorite books, The Privileged Planet.
Yeah.
Guillermo Gonzalez, I think was his name.
Yeah, and Jay Richards.
And Jay Richards, an astronomy professor, I believe, at Iowa State. And he ran into all kinds of problems, even though he had published a very popular college-level astronomy textbook. And basically, they denied him tenure because he even did what you did, suggest that this may be pointing in the direction of a creator. Have you experienced any of that type of protest or repression as you're in your college professor career?
No, because it didn't really come up a whole lot in the classes that I taught. I taught mainly physics, and there it's just theory. There's no controversy there. In my astronomy classes, there wasn't anything I taught that was really particularly controversial. So it just didn't come up for me. Maybe if I'd stayed at the university longer, it would have. But I certainly knew the attitude of some of my fellow professors, and had I decided to go for tenure, that very well could have counted against me, because there were times I discussed it with my students. I can do it more now. I teach at actually a Jewish high school now, so I can, where a lot of students are atheists. So I can, but it's way more common than you think. But it does allow me to have this kind of conversations. Even though it's sort of a religious school, but it's also a liberal school, and they have this sort of odd relationship with their beliefs. I can at least talk about God and not be run out on the rail, sort of. So in the future, something like that may happen. It hasn't occurred to me, but yes, it definitely has occurred to other people.
In 2004, when that book was published and Jay and Guillermo posited their ideas. The first half of that book was pretty much a recounting of your presentation, the anthropic principle, and the necessary conditions for life. But I wonder if you could give your own personal perspective on the second half of that book, which posited something new, in which they claimed that the conditions that are necessary for life are also the same critical necessary conditions for exploration of the universe. And since that book was written nearly about 14 years ago, whether there have been advances in astrobiology that would continue to suggest that that premise is stronger than it was at that time, or if it remains the same.
First of all, the book is on my Kindle. I haven't actually read it yet. It's on a very long list of books for me to read, but I know the argument. I've read summaries and I've seen presentations by Jay Richards, actually, so I know basically what they're saying. It's certainly their science can't be argued with. I mean, their facts are straight, which is usually the case in a lot of these. You can't argue the facts. People don't argue with is the interpretation. And certainly the idea that they're saying is that we're living on a planet that, again, is in the right place in our galaxy. We're just outside of what's known as one of our galaxy's spiral arms. So there's nothing blocking our view of the universe. The spiral arms are filled with dust clouds and nebulae and all this stuff that would hurt us and block us and all the rest. And we don't have that. We have an atmosphere that's clear, unlike, say, Venus, which is completely clouded over. All these things that are necessary for life do allow us to observe, and we are at the right place in space to observe it, and we're in the right time to observe. As we already mentioned, that before now we couldn't have existed. After now, anytime you go much further than what we're going now, we see less and less and less the universe is getting too far away from us as dark energy really begins to push it out. And so, I would absolutely agree with their statements that we are not. It's not just that with the universe's plan to allow us to exist. The universe is planned to allow us to exist and appreciate it.
Here we go.
How first part of the Genesis, when God said, God created the heavens and the earth. When does that come in with your?
I thought someone was going to bring that up. My interpretation of Genesis, obviously, I believe God created the heavens and the earth. I mean, I think, right from the beginning, God created. I think that's the simplest and best explanation for everything. After that, the whole, young earth, old earth, obviously I'm an old earther. When I read Genesis, I think it's a straightforward account of creation. I think it's sort of a broad strokes account of creation. He's not going into a lot of detail because that's not the point. And sort of a side note, I always find it interesting, people are like, well, why didn't God write us a more detailed of account of creation? And, people say, well, people back then wouldn't have understood it. Well, why do we think we would understand it? God, we haven't even come close to understanding everything. If God gave us all the details, we'd be lost. So I think it is a very broad strokes. I believe that Genesis, I think when you read Genesis, it's sort of narrative, but it's not typical narrative. It's sort of poetic, but it's not strictly poetry. Again, I think it is literal, but I think it's literal in a very sort of stylized fashion. I think that it most likely started as an oral tradition. Then that in no way negates its truthfulness or its inspiredness. It's simply, I think it started out as oral, and that Moses recorded an older oral tradition, possibly passed down from Abraham or even before that. And that its structure, the idea of the 6 days of creation, a lot of the parallelism, is that really strongly echoes a lot of other oral traditions, and it's there to make memorization easier. So instead of being literal 7 days, I think we have these, or 6 days for creation, I think we have these 6 periods, these divisions that are called days to organize the information. And it is presented, I think, chronologically. I don't think like day 4 happened first or anything like that. But it's not like a regular every day is 1,000 years. It's not, I don't think it's I don't think it's 7 24-hour days. I think it's an account of a creation that takes place over a longer period of time that's just organized in that fashion to make it memorable. But I absolutely do think it is creation. I'm not a theistic evolutionist. I certainly don't think the universe happened into existence. I think that God created, and that God's hand was necessary at every step to produce a universe and a world like we have now. I think left to its own, this planet would not exist.
Left here.
I want to follow up a little bit on what she just said. That was on my mind too. I just read Genesis 1 before I came here, and it turns out that on day 3, whether it was 1,000,000 years or 1,000 years or a day, however you look at day 3, God kind of completed planet Earth with land and seas, and then he put the plants on planet Earth. And then on day 4, he put the stars out in the sky. Okay, according to Genesis 1, the way it reads. So if day 3 came before day 4, it seems like the Earth was before the stars. What I'm saying, it doesn't jive with what.
Yeah, so actually it makes a lot of sense if you think about it. First of all, think about the if you look at the passage, it's not saying that, it really actually doesn't say the stars and the sun and moon are created then. It's saying let these be, in the skies for purpose of us, times and seasons and the like. And if you look at the history of how the earth formed, which we have a pretty good handle on now, the early earth, really early, has an opaque atmosphere. It's completely covered in clouds like Venus is nowadays. Over time, this atmosphere begins to clear out until it's translucent. It's not clear, but it can start to let light in. And I think that's where day 1, I think in the beginning God created the heavens and the earth. That's basically Big Bang. Day 1 is this clearing. It's allowing light into the earth. And then, there's light on the earth, so you can have plants and things. But the atmosphere actually didn't get clear, transparent until much later. And it wasn't until then that you could actually see that there was a sun and a moon and a stars there. And that's when you could really start to divide up the times and the seasons and the years. And I think that's what day 4 is. I think it slots in perfectly with how we know the earth developed. Which again is a great argument for divine inspiration in Genesis 1, that a person making this up would not have put the sun and the moon and the stars after plants. They would know better than that. But if you think about it as being, this is what you would see from the earth, it fits in perfectly.
I think Jeffrey mentioned Reasons to Believe, which is an organization it's a ministry on the West Coast that was founded by a Canadian astrophysicist by the name of Hugh Ross. And he spent his life sort of devoted to this particular question. As Rod, who's the chapter leader here, if you don't mind me stepping in on your place, as we're dedicated to the idea that the biblical story and the story of nature are completely compatible, and they must be because they are both creations of God. And it's just a matter of us working at this and finding out and trying to understand how these things fit together. If you want an interesting book about this, Hugh wrote one several years ago called Navigating Genesis. That's one of the better descriptors.
Oh yeah, very good book.
Which takes you through this whole process and shows you how the actual, and he's very, very respectful of Scripture. He's a pastor himself, very respectful of it, and he will show you how that fits with the biblical narrative that we see when we read it. Of course, I'm a linguist, so we're reading it in English, and it was written in Hebrew from 3,000 years ago, and it's very complicated, and it's very difficult to sort of make those transitions around words like day and stuff like that. But he'll take you through that and be very good. And also, is that Ray's book?
Yes.
Oh, we go the long way. We'll both go the long way. We can chase each other around the group here.
Ray, would you like to stand up and introduce your book?
I'll introduce your book. This is Ray's book. It's called Science, is the Bible versus Science or Not. Ray's been very active on the board of the Areopagus for many years, and this goes through the same sorts of issues, from a man who is a lifelong Bible teacher, so forth as well. So I would recommend that equally as well with Hugh Ross's Navigating Genesis. Rod, anything you want to add to that? No? Okay.
Yes, a question along the intelligent design and probably somewhat related to the question we had over there is, this idea of designer God, how much do you think that many of the scientists are rejecting the idea of intelligent design or designer God just because they reject the supernatural? Therefore, it doesn't matter, but if it could be 99.99% inference, that's where it points, that's not an option. Therefore, we can't go there. How much of that is...
Oh, that's a lot of it. And I think you put your finger on a big thing, the idea of a paradigm, that these scientists are working within a particular paradigm that doesn't allow for the supernatural. And that's really important to keep in mind because a lot of Christians get kind of a persecution or a conspiracy mindset to think, oh, the scientists out there, they know the truth, but they're hiding it and covering it up, and they're, and that's not it. They're working out of a different paradigm that does not allow for that explanation. And if you do not allow for that explanation, if your worldview doesn't account for it, you're not going to see the evidence in that way. You're going to see the same facts, but your interpretation will go another way. And it may be more complicated than the supernatural God did it explanation, but since their worldview doesn't allow for that, then they're going to go with what to them is the least complex. But yeah, I mean, that's a very big part of it, because until the idea of not allowing a supernatural became a part of science, most scientists saw these facts as evidence for God. Isaac Newton certainly did. Johannes Kepler, probably my favorite astronomer in history, certainly did. He described science as thinking God's thoughts after him, and it wasn't a metaphor for him. He really meant that. And a bunch of others as well saw this, saw the regularity and the rationality of the physical laws they were discovering, and deduced that it came about due to a rational lawgiver. And it's only more recently, when the science paradigm has shifted towards methodological naturalism, that you can't allow the supernatural foot in the door, as I think that might have been Dawkins or someone else.
No, Lewontin.
That's Lewontin.
Lewontin, okay. Who said that? That's really begun to change. So it's a paradigm. It's a worldview issue. It's not hostility. Not for most of them. Some of them maybe, but for the most of them, it's not intentional. It's just that their worldview does not allow for that explanation.
Why do you think that?
That's a whole talk in itself. Goes back, to the Enlightenment, the introduction of ideas from people like Kant and Hume and Hegel that were the first to sort of reject the idea of God interfering in the universe. And, someone like Jeff might be able to answer a question like that better than I could. But yeah, it really, comes into play, starts coming in the late 1700s, really gains steam in the 1800s.
It's interesting to know, we talked about Newton. And when Newton was living at a time when this materialist, physicalist approach was really coming on stream hard and fast, that everything was physical interactions. And when he proposed his theory of gravity, even though it covered the waterfront, it covered the data, it explained what was happening, he was proposing that there were things which acted at a distance. Right? These planets didn't have to be next to each other to have this force of attraction being affect them. It was acting at a distance, and they thought that just like today's materialists would reject any supernatural explanation of a God, for example, in the creation of the universe, they said this was crazy. You're doing damage to science. You can't do this. You can't introduce these things. Right? It's not right. It doesn't fit our current paradigm. So the question then becomes, when you look at the paradigm, and as Eric says, they have a materialist paradigm, and they reject the supernatural. So then the question becomes a philosophical one. What determines what's appropriate as part of your paradigms? That's not just one more night, that's 5 more nights to talk about that. Yes, we're getting close to the end. We have one more? One more.
So what do you think about the idea of like an ideal time theory, where rather than God creating 14 billion years ago, he instead created something like 10,000 years ago, but created an old appearing universe? So like everything around us appeared old and the earth seemed old, but in all reality it's only 10,000 years old or so.
Well, to put it very bluntly, I think that makes God a liar. Because God tells us to learn about him from the universe. He says, we witness the firmament, we see the world around us, and that tells us about God. It tells us that God is there. And if God creates a universe that deliberately looks old and is not, then God is actively creating a universe to deceive us. And that is utterly and thoroughly against the character of God. If God had created the universe 10,000 years ago, we would be able to tell it. And I mean, it would be obvious. And even if he created a universe that was capable of supporting us, there are things that we see on this earth that are much older than that don't have to be. So if God has created them to look old when they're not, to me, that's something that's completely against God's character.
We've just about finished our formal time. Would you just show your appreciation to Eric one more time?
Thank you.
If you